Let's do a couple more examples of finding domain and range from a graph and determining whether or not we have a function. Remember, to determine if you have a function, you need to do the vertical line test. If you can draw even one vertical line and hit your graph in two separate spots, remember this means that it is not a function. Because it failed the vertical line test. Even though it's not a function, we can still find the domain and range. Remember that your domain is your x values. So if we're reading from left to right, we're looking for smallest to largest, we start having ordered pairs at x equal to -4. We may not be able to include -4 from that top piece because it's an open circle, but in the bottom piece, we do have a closed dot, which means that we can have a bracket on -4. When we move to the right to find our largest x value that we use, we hit -2. And because we actually have -2 as part of an ordered pair, we're going to use a bracket. Next, we need to find our range. Remember, range is y. And we're going to go smallest to largest again. Starting at the bottom, our smallest y value is at -4. And because it is a closed circle, we're going to put a bracket. When we scroll up to find our y value, our ceiling is at 4, but we have an open circle, which means that we're not actually going to hit 4. So my +4 needs to have a parenthesis because I will not actually get to a y value of +4. Looking at our next example, still need to determine if he's a function. So let's go ahead and do the vertical line test. So far, he's okay. Uh-oh, now we're not okay. Remember, it's just got to be one place where we hit our graph twice, and it immediately is not a function. So since he failed the vertical line test, he is not a function. Even though he's not a function, let's go ahead and find this guy's domain and range. As I'm sure you are getting sick of hearing, domain is x. And we're working our way from left to right, smallest to largest. The smallest x value that we get close to is our -4. And I say get close to because it is an open circle, which means I'm going to have an open parenthesis. And now we need to find out the largest x value our graph takes on. So scroll to the right and we get x equal to 1. And if you put a parenthesis, look at the graph again. We have a line in the way, so let me get rid of that. But notice that there's no open circles here. So if you put a 1 with a parenthesis, you need to go back and fix it. It is a bracket because we can actually hit 1. It doesn't matter that we have the open circle over here because that's when x is equal to 0. And x equal to 0 is closed down below it. And let's look at the range. Remember, range is our y values, smallest to largest. Our smallest y value starts at 0, and we actually hit it, so we're going to use a bracket. And then as we travel up, we hit a ceiling of 4, but we had an open circle, so we're going to use 4 with a parenthesis. Last one like this. Here, if we do the vertical line test, it gets close, but we actually do not hit our graph more than once with any of our vertical lines, which means that this guy is a function. Looking at our domain, our x values, we can see our smallest x value is at -5, and it's a closed circle, so I'm going to put a bracket. When we scroll over to the right, we see the highest x value is at 5, but because it has an open circle, we're going to put a parenthesis. Looking at our range, which is our y values, starting at our lowest, the lowest y value is -3. And we had a closed circle, so I'm going to have a closed bracket. Our highest y value is a 2, but it has an open circle, so we need the open parentheses. And now we need to review domain of functions actually written in algebraic form. So not from a graph and not from ordered pairs. Example 2, we're asked to find the domain and interval notation of the following functions. You have to identify what type of function you have, and then you can figure out the domain. With these two guys, you may be missing them at this point in the semester. These guys are both polynomials. They do not have negative exponents. They do not have variables in a denominator. They do not have fractional exponents. They don't have radicals. Nothing crazy going on. It's a polynomial, which means that its domain is immediately negative infinity, positive infinity. Same thing with the guy in part B. No negative exponents, no fractional exponents, no variable in a denominator, and no radical. He's a polynomial. Domain immediately negative infinity, positive infinity. But in example 3, we do not have polynomials. We have radicals. There are 2 rules for radicals, or 2 cases. The first is when your index is even. And the index is that little number on the radical. If your index is even, set the argument, what's under the radical, greater than or equal to 0, and solve. And that's because with our domains, we are staying in the real numbers. So we're not going to be doing infinities. Sorry, not infinities. We're not going to do imaginaries in our domains. Our second case, if your index is odd, then immediately your domain is negative infinity to positive infinity. And that is because we can take an odd root of a negative number. For instance, we can take the cube root of -64 and get -4. We can take the fifth root of negative 32 and get negative 2. We can also get all of those with the positive side too. Cube root of 64 is 4. The fifth root of 32 is still 2. Okay. So when you're looking at your radical functions, you need to find the index. If you do not see it, it's a 2. So in our first case, our index is 2, which is even. We are going to take what's under the radical and set it greater than or equal to 0. I don't care about the 7. He's not under the radical. When we solve this, we would get x is greater than or equal to negative 15. And we discussed in previous lessons that we could always do our number lines and sketch it to figure out our interval notation. We need to be bigger than negative 15, which means we're going to the positive infinities. And this time with the greater than or equal to, we need a bracket. If it was strictly greater than, we would not use a bracket. We would use the parenthesis. But here I can see that my domain is negative 15 to infinity and beyond. Part B. Index again is 2, which is even. So I only want to take what's under the radical, set it greater than or equal to 0. So 4 minus 2x greater than or equal to 0. Because after we get below 0 under the radical, we're getting into the imaginaries. Subtract 4 from both sides. We get 2x is greater than or equal to negative 4. And here, when we divide both sides by negative 2, we need to stop and flip the sign. Whenever you multiply or divide by a negative number, so since that 2 is negative, we need to flip our inequality sign, which means we're going to have x is less than or equal to 2, because negative 4 divided by negative 2 is positive 2. If I were to graph this to get my interval notation, I would have a bracket at 2, and I need to go less than. So I'm going to go into the negatives. I'm going to go smaller, which means my domain is negative infinity with a parenthesis on up to 2 with a bracket. In part C, our index is 5. Since 5 is odd, we immediately have the domain of negative infinity to positive infinity. We can plug anything we want into that function and we will stay in the real numbers. And I know you thought you could get away from them, but they're back. You need to remember how to use your rational functions. Remember, your rational functions are your fractions on steroids. They have variables in the denominator. And to find the domain of a rational function, we need to take our denominator, set it equal to 0, and solve. Because they're not asking you to simplify, you could use the quadratic formula here, but this guy also factors. You'd be looking for a product of negative 42 and a sum of negative 11, which means that we would need 3 and negative 14, because 3 plus negative 14 gets us to negative 11. Since the 3 is positive, I'm going to have x plus 3 an x minus 14 since it's negative. My leading coefficient was 1, which means when I do the division, it doesn't change anything. I have x plus 3 times x minus 14 equal to 0. By the zero factor property, we find out that x cannot be negative 3 and it can't be 14. These are our restricted values, if you may remember. And if we're looking at interval notation, negative infinity on the left, positive infinity on the right, we need our negative 3 near negative infinity. We need our 14 near positive infinity. And remember that we cannot include either one of these. So I'm going to go ahead and X those out. That means our domain is going to be negative infinity to negative 3, union, now I'm in the middle, negative 3 to 14, union, jump rope, over the 14, and then 14 to infinity. So everything that we've been learning, you cannot just dismiss or erase from your head. We're going to need it for the rest of the semester.